So I promise that I'll motivate the need for executing ML models trustlessly with several applications. And I'll first start with trustless audits. So why do we care about this? Well, as ML increases in the different uses and scenarios, we want to be sure that the models that we're running satisfy some properties. For example, for medical ML, you might want to ensure that the training data set conforms to some regulations, for example, by the FDA or some other regulators. And also recently, Twitter open sourced their algorithm, and you might want to ensure things like my timeline isn't biased. But of course, Twitter has a bunch of private user information that they are not allowed to release due to regulatory reasons. But they still might want to show that certain properties like this. So how can we accomplish this with ZK snarks? Well, we'll use two steps. The first step here is the proof of training, which unfortunately also has two steps. The first thing to do is to commit to the training data. And so, for example, you might want to commit to the images you're using for training a medical ML model. And then you can, in fact, unroll the entire training process. One common method of training ML models is using what's called stochastic gradient descent. And you can produce ZK snarks of the training process to ensure that the model that can be committed to at the end in a hiding manner was actually trained on the data that you committed to originally. Then you can compute these audits trustlessly. And in general, these audits take the form of a function of the data and the weights. And in particular, all of these can be hidden using the process I described in the previous slide. And as I mentioned, there's many different kinds of audits that you might want to run. For example, that your data isn't biased for medical ML, that your model performs well, also, for example, for medical models, and say that your timeline isn't biased, and a whole host of other things that consumers might want to know about the models that they're consuming. Another important type of audit might be that your training data doesn't contain any copyrighted images.